All right, look at this freeform motion. Okay, an apple is, let's say, an apple is being thrown up, and then it fall back down, and then go below the origin. Okay, the whole process is still called freeform motion, although the first part here, when going up, doesn't look like it's falling down. It's still considered a part of the freeform motion. Okay, it's still considered as a part. The front part here also still considered as a part of freeform motion. As I said before, going up or going down, as long as it only involves one component, which is the y component, then it is freeform motion. Okay, accelerate when, and also the acceleration must be negative g. Okay, now so this whole thing is a freeform motion. Okay, going up and down. So now I want to talk about the difference between displacement, velocity, and acceleration at different part of the motion. This is important. Okay, this is important. Hold on a second. All right, let's continue. Okay, so if you look at this graph, okay, let us first look at the first part. Okay, I want to break it into 3 parts. Okay, the first part is going up, okay, until the top position, and the second part is here, going back to the origin, falling back to origin, and then the third part is going below the origin. And I want to discuss the displacement, velocity, acceleration for each of these different parts. Okay, and also especially I want to emphasize about the top position here. Okay, about the top position here. Right. Okay, you see, let's look at the first part. First part is the object. Okay, first of all, you need to see the origin. Let's say the ball is being thrown up here, the object firstly is start over here, so we consider this level as origin. You see that this is the origin, s equal to 0, origin. Okay, now you throw the apple up, so the object go above the origin, the apple go above the origin, so displacement is positive. Okay, what does it mean by positive displacement? Positive displacement means object at above the origin. Above the origin. So for when the object over here, it is above the origin. So that's why displacement is positive. Okay, not because it moved up, it's about the position. Once again, I want to say that about displacement is about position. Where is the final position? Where is the final position compared to the origin? This one is more to final. Displacement is more to final position compared to origin. Is it above or below origin? If above origin is positive, if below origin is negative. So the object moved up to here. This is the final position. This final position is above the origin, so that's why displacement is positive. Okay. Now, how about velocity? Velocity, for the first part, it is the motion. When talking about velocity, it's more to motion, the movement. The motion of the apple is moving up. The direction of the motion is moving up, going up. That's why going up, velocity is positive. Because the apple is moving upwards. That's why velocity is positive. Velocity positive because of the apple moving upwards. Okay, velocity positive. Now, how about acceleration? Okay, so the apple is being thrown up. It's being thrown up. It already released from the hand. You understand? Already released from the hand. Already released or not in contact with the hand, you know, the human hand who throw the apple up. Not in contact with the hand anymore. So no more pushing force from the hand. No more pushing force from the hand because not in the contact with the hand anymore. We can just plainly say that the hand already provide an initial velocity for the apple to move up. Once it is released from the hand, not in contact with the hand, no more pushing force from the hand. So the only force acting on the apple now is only the weight. The sole influence. So what is meant by free fall motion? The sole influence of gravity. Only the weight acting. You can just write an only, yeah? Only the weight force acting on the apple. Okay, so now for this, also we assume no air resistance. This one is in vacuum. Okay, we assume in vacuum. Okay, assumption. My assumption is no air resistance. Okay, vacuum. Okay, so the only force acting on the apple now all the time is only the weight. Okay, no matter where is the object, no matter is over here going up, the force acting is the weight. At the top position, let's say this one at the top position here, the force is also the weight. You see, also going down because gravity always downwards. When going down, also the weight is also downwards. When over here, when going at the bottom here, the weight also downwards. You see that? So since the weight is downwards, also we also derive already the weight contribute for the acceleration due to gravity. You see, acceleration due to gravity because of the weight. Okay, let's look at here. Okay, so the resultant force now, that's why I say acceleration follow the resultant force. So A is negative. For this case, talking about the acceleration is negative g. It's negative g. Why negative? Because the resultant force, equal to ma, the resultant force is only the weight. Only the weight. So mg equal to ma. So that's why a equal to g, or we can say a equal to negative g because downward. Yeah, a equal to negative g. So so because the weight is downward, that's why a also downward. That's why acceleration also downward. So no matter where is the apple, where the apple going up, apple at the top, apple going down, apple at below, the force acting all the time, the only force acting all the time is only the weight. Only the weight. So the acceleration always constant. So what I can say is, for free fall motion, the acceleration is always negative g, and the acceleration always constant and always directed downwards because gravity is downwards. Okay, so for free fall motion, the acceleration is always constant. Even at the top position, when velocity has already decreased, becomes 0, it still has weight. The apple still had weight. So the acceleration still constant, negative g. Okay? So you see, can you see that? The acceleration is always negative g, negative g, negative g, negative g, no matter where is the apple. Okay? Now, I just want to rub this off, yeah? Just want to rub this off, make it not so complicated. Okay, so now the apple going up, is it accelerate or decelerate? Is it accelerate or decelerate? I don't want to talk about accelerate or decelerate first. Okay. Okay, I just say that the apple decelerate. Of course, when the apple going up, it becomes slowing down and slowing down. Finally, velocity becomes zero. Okay, velocity becomes zero. But at the top position, it still had the weight. Okay, it still had the weight. So it still have even velocity is zero at the top, but it still has gravity. So acceleration still constant, directed downward. So A is still negative g. Yeah, at the top here, velocity is zero, but the acceleration still negative g. Okay. Okay. Now, the ball go downward. Second part. I want to talk about second part. The ball go downward, okay, to the origin. So from here to here, the ball is still talking about position. Let's talk about the position first. The position is still positive displacement. Positive displacement because the position compared to the origin, the final position is still above the origin. You see that? It's still above the origin. So when the object is the final position still above the origin, the displacement is positive. So when you're talking about here, 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 over here, all of these positions still above the origin. So displacement still positive. Okay, velocity. Velocity is the object, the apple is going down. Apple is going down. So the motion is downward. Motion is downward. So velocity is negative. Because talking about motion, when velocity moving downwards, velocity become negative. So this velocity is negative. Okay. But the acceleration still negative g, never change. You see, acceleration is always constant all the time. Just when you pay attention to acceleration, it's always constant all the time because all the time, the total force is the weight. The total force is also what I can say is the total force is also always constant all the time, constant and downward. Yeah, the total force is the weight only. Okay, that's why the A also constant all the time. Okay, so A is downward, and when the ball fall down, velocity increase. Yeah, it become faster and faster. Accelerate. So the object accelerate, become faster and faster. Okay, so displacement is still positive, but velocity because going down is negative. Acceleration follow the resultant force. The resultant force is downwards, so acceleration negative. Your resultant force is downwards, so acceleration negative. Okay, all this position, the resultant force is all downwards because of the weight. Because of the weight, so the resultant force all is equal to the weight only, all the time. So that's why the acceleration all constant, all directed downwards, all equal, A equal to negative g, constant. Okay. Okay, that's the second position. Now third part. Okay, if the apple already go back to origin, go back to the same level, means displacement now is zero. Okay, displacement now is zero. Now the apple now drop down further. Maybe this apple is being thrown up from your hand, but then the apple drop to the ground below your hand level. Yeah, go to your leg. Maybe like that. Yeah, or you throw the ball up from a building, throw it up, and then it return to the same building. But then go to the ground below the building. That is what it means, yeah, by negative displacement. When the apple go further down below the origin, okay, below the origin. So when the object is below origin, displacement is negative, below origin. Below origin, displacement negative. Okay, the final position compared to the origin, this is the negative displacement. Now, about velocity. Velocity, the object still moving downward. The motion is downward. Motion downward. Talking about the motion, object moving downward is velocity negative. So velocity negative. Okay, good. Acceleration. Acceleration still constant negative g, because the only force acting now is only the weight. So the weight brings the acceleration due to gravity. So A equal to negative g. Finish. Okay, finish, but not yet. Okay, one important thing to discover. Okay, one important thing to discover. You see here, going up, we know is decelerate, isn't it? Decelerate. What makes sense that this object decelerate? From what you have learned before about this, when velocity and acceleration same direction, object accelerate. But when velocity and acceleration opposite direction, the object decelerate. What is this situation? Make sense of this table. I want you to make sense of this table and clear off the misconception you have all the while. Okay, this is wrong, because this one just look at the acceleration without looking at the velocity. You just assume that, oh, acceleration positive, accelerate. Acceleration negative means decelerate. If you think like that, just look at one acceleration, then this cannot be applied to this situation. Look. Okay, look at the first part. We know that this apple, when going up, it becomes slowing down, isn't it? It's initially when you throw upward, when you throw, okay, just want to rub this off. Okay, you throw this upward, you throw the apple upwards. So the apple initially is very high velocity, and then it becomes slowing down until the maximum height. And at the maximum height, it has zero final velocity, but it still has the acceleration due to gravity. Yeah, A is negative g constant. Okay, now we know that it's slowing down, isn't it? When going upward, it's slowing down and decelerate. Okay, we know that velocity is positive because moving up, but A is negative g. Okay, A is negative g because gravity is downward. So why do you say this apple decelerate instead of accelerate? Because velocity and acceleration opposite direction. Velocity, one is positive, one is upward, one is downward. Velocity is positive upward, acceleration is negative g downward towards the gravity, towards the earth, the center of the earth. So one upward, one downward, opposite direction. When velocity and acceleration opposite direction, object decelerate. Object decelerate. The object is going upward, but the weight is pulling it down. You understand? The weight is pulling it down. That's why it becomes slower and slower, because the acceleration not in the same direction with velocity. So that's why the object will, when the acceleration and velocity not in the same direction, the apple decelerate. Okay. Now look at the second part. Oh, can we say that acceleration is negative, so decelerate lah? Acceleration negative, so decelerate. So when the object falling down, it becomes decelerate, becomes slower and slower. Is that correct? No, when object falling down, it accelerate. So when you say acceleration negative, it decelerate, it's wrong. Misconception. You need to look at the velocity. Right now, velocity and acceleration, same direction, they accelerate. So do you see how wrong is this? Okay. So the acceleration is downward because it follow the weight. Weight is downward also. All right. So now you see, velocity is going down. Velocity is going down. Okay, you see, velocity is going down. Velocity is going down. Acceleration also downward because the weight is downward. It's like the object is going down. The object is going down, and the weight is pulling it down further. So in this context, acceleration and velocity is in the same direction. The acceleration and velocity is in the same direction. Of course, when velocity and acceleration in the same direction, both negative, both downward, the object accelerate. Okay, you see, because both of these velocity and acceleration, the acceleration is in the same direction with the velocity, in the same direction, both negative, both downward. That's why the object accelerate downward. You cannot say, oh, A negative means it decelerate. No. This A negative, but the velocity is also negative. Same direction. So velocity, if the acceleration is same direction with the velocity, the object accelerate downward. Okay, that's the second. Now, yeah, so both when V negative, A also negative, same direction, the object accelerate. Now, look at the third part. Look at the third part. This actually this part is the same as the top part here. You see that? Because this object also going downward, velocity is downward. Okay, acceleration also downward because it follow the weight. The weight is downward. So the resultant force is downward. So the A also downward, negative G. So now the acceleration also in the same direction. The acceleration is in the same direction with the velocity. Since they have the same direction, the acceleration is same direction with velocity. So this object accelerate downward. Accelerate downward. So when both going downward, both same direction, V negative, A negative, same direction, accelerate. Okay, are you clear now? That's about free fall motion. All right, that's about free fall motion. So remember, displacement is for displacement always you need to refer to origin. For first and second part, the displacement is both positive. For the third part, displacement is negative because below the origin. Velocity, just look at direction of motion. Going up, positive. Going down, negative. Going down, negative. Acceleration, just look at the weight. The weight, yeah? The resultant force. The resultant force is all going downward. All going downward. So, acceleration all also downward. All is a constant. Okay? So, that's all for free fall motion. Good luck.